Hello everyone, welcome back. New episode of Dr. Eigenstate Explains coming at you here. I can't get the notifications to go away. I don't know how. I don't know Apple products. I apologize. I'm deeply sorry. If anybody knows how, let me know in the comments. Anyway, so in the last installment we talked about some things. We're going to start getting in a little bit of cosmology here, just shake things up a little bit. The last thing we talked about was galactic redshift. And as many have probably figured out, galactic redshift implicated something pretty, it was very much a paradigm shift in how we viewed the universe, viewed how it behaves. And that's what we're going to talk about in today's video. We're going to talk about the expansion of space-time. Also known as the expansion of the universe. I like to say the expansion of space-time because the thing that's actually doing the expanding is space-time, or more specifically, we'll get into those details here shortly. Object eraser, yes, that's exactly what I want. Sweet, goes a little bit faster. So galactic redshift is what we talked about in the last video, and that leads into the expansion of space-time. Yes, space-time is expanding. So we saw in the last video, there's two measurements we can use. The one that is still commonly used if we're trying to make measurements is the measurement that we utilize that we get utilizing the cosmic microwave background radiation. If we remember, I'm going to be rounding here just to make it easy. It's about 67 kilometers, if I can make an M, per second per megaparsec. And a megaparsec is 326 million light years. 1 parsec is 3.26 light years. So naturally a megaparsec is a million parsecs. That's 326 million light years, which is that's a pretty big distance. I'm not gonna lie. It's actually quite large. So this number that we get is often referred to as Hubble's constant, the amount by which space-time is expanding. The first thing that I want to mention about the expansion of space-time is, number one, it's not, the thing that you need to know is that a lot of people ask, well, what is doing the expanding? And the response would be space-time, but more specifically, it's the scale of distance in space-time that is expanding. So if we're, say, here at some location and we observe, this is going to be a really shitty galaxy, but when we observe some galaxy that is 326 million light years, or 1 megaparsec away from us, so this is 1 MPC, megaparsec, that looks like an E, I know. Let me try that again. Away from us, we would observe it to be moving away from us at about 67 kilometers per second. That's how fast away it would be moving. That's how fast, I guess you could say, space-time is carrying the object away from us. Then if there was a galaxy that was another megaparsec away, we had another little galaxy here. So that's 2 megaparsecs away from us. It's going to be going not 67 kilometers per megaparsec, but 67 times 2. What is it, 132 kilometers per second? 134. It's 2 off. 134. So we're going to be seeing this moving at, from our perspective here, we'd be seeing it moving at 134. Not 113. 134 kilometers a second. However, if we moved to this galaxy and we're observing this galaxy over here, from this galaxy right here, what we would observe is this galaxy here moving away from us at 67 kilometers per second. And that's why it's 67, I'm getting a little ahead of myself here, 67 kilometers per second per megaparsec. Every increase by a megaparsec that you go, you're going another 67 kilometers per second faster. And that's why it's 67 kilometers per second per megaparsec. So the speed at which something is moving away from you, I guess you could consider it logarithmic to an extent, that for every megaparsec you increase, you're going to double the amount by which you're moving away from us. So it's going to increase by 67 kilometers per second. And this is why the further away a galaxy appears, the redder it appears to us, because the faster it's moving away from us. And like I said in the last video, what that really means is that it isn't actually physically the galaxy that's moving at all. It's the space in between us and that galaxy or other object. It could be some other object, generally galaxies. The distance between us and that galaxy is growing. And so the more space you have, if space is expanding, the more space you have between two objects, the more space there is to expand, the more expansion you're going to get. If you can imagine drawing dots on a balloon, well, as that balloon expands, those three dots are going to get further away from each other. And then, as it expands even more, they're going to get even further away from each other, because the dots themselves are not moving on the surface of the balloon. The amount of balloon between the dots is stretching. It's expanding. And so that's one thing that we need to understand when we're talking about the expansion of space-time, is that it's sort of a logarithmic expansion of the scale between two things in space-time, because space-time is expanding. The other thing you need to remember is another question that I'm sure many people that talk about this, that know this stuff, have probably either heard or asked themselves. It's a question many have asked me, is, well, what is the universe? It's expanding. Awesome. What is it expanding into? The answer to that is nothing. The expansion of space-time, or the expansion of the universe, is not to be thought of as the universe being some physical object that is getting physically larger in some otherwise pre-existing space. The expansion of space-time is, as I said earlier, to simplify it a little bit more, is a metric expansion of the scale of space-time. That's really what the expansion means. There isn't, the universe is not like bounded, and this boundary is just flying off into a void of nothingness, and the universe is physically getting larger. That's not the right way to look at the expansion of space-time. It's that over sufficient enough distances, 2 points will grow away from each other due to the massive scale of their distance. Space-time expands outward, and carries with it objects away from each other. But it's not expanding into anything. That's just not really the right way to look at it. The whole concept of outside of or beyond space-time is, in terms of physics, is incoherent anyway. It doesn't make sense, at least as far as we know, but that's a topic for a different day. That's really what the expansion of space-time is. It's the metric expansion of the scale of distance in space-time between two objects. The further away those objects get, the faster away they will move from one another as a result of space-time expanding. Well, why is space-time expanding? The easiest answer to that question is, well, the Big Bang. Inflation happened, and then the Big Bang, and that kind of drew space-time apart in a sense, and it's continued to do so ever since. But it's also worth mentioning, as I'm sure many of you in the audience will know, space-time is accelerating in its expansion. So it's not just expanding at a steady speed, the rate of expansion is accelerating. This is due to something called dark energy. We're not quite sure what dark energy is. The leading hypothesis, at least currently, is that what we call dark energy is fundamentally just the vacuum energy inherent to space-time itself. But that hasn't really been confirmed, though it is the leading hypothesis. So, short video here just to explain what the expansion of space-time really is, what it really means, and just to reiterate, the universe is not some physical object getting physically larger in an otherwise pre-existing space. When we talk about the expansion of space-time, we're referring to the metric expansion of its scale logarithmically as distance increases. You will see those objects begin to move away from each other. This can be measured. One of the primary ways of measuring this is with redshift. So that is what the expansion of space-time is. And the next video we're going to start getting in a little bit more into some of the abstract stuff in cosmology and what it really means and some misconceptions that come along with it. So definitely stay tuned. We're starting to get into some more juicier stuff. Might be some philosophy involved in there as well, because with topics like these, oftentimes you can get into that. Some people don't see that, and that's again, that's a different discussion, but stay tuned. We've got some good stuff coming up. And as always, per causam nos perfectum, or through reason we progress.